Welcome to NASA's Jet Propulsion Laboratory in Southern California. We are gearing up for NASA's Perseverance rover to touch down on Mars. Happening in an hour and a half from now, the rover will attempt to land in Jezero Crater. It is the most difficult landing site on Mars ever attempted. Thank you for joining us. I'm your host, Raquel Villanueva. In the past, mission team members gathered in our mission control for landings. But this time around, we have COVID safety measures in place. Today's landing will look a little different than what you've seen before. I am in a room by myself, and so is my co-host. Here in the Space Flight Operations Facility, team members are in different parts of this building. Some are in mission control, others are upstairs for landing operations. We also have isolated rooms for our guests on this show. In total, we have 8 locations covered by 14 robotic cameras that you will be seeing. One of those locations is the dark room, the heart of NASA's Deep Space Network. Think of it as a giant communication switchboard. This is where spacecraft phone home to us from across the solar system and interstellar space. The Deep Space Network has been tracking Perseverance since it left Earth, and there are lots of ways you can watch landing today. We have a 360-degree camera inside the control room. It lets you experience the landing right along with the team while seeing this broadcast. We also have the clean feed. It shows an uninterrupted view of mission control and audio. También tenemos un programa en español. To tell us about it is host Diana Trujillo, who also works on the mission.
Thank you, Raquel. We're so excited to be the sister live broadcast in Spanish. Sintonízate nuestro programa en las redes sociales de Twitter, YouTube y Facebook en la NASA en español para que nos acompañes a un tour virtual de la NASA con entrevistas con astronautas, con participación de artistas, con entrevistas con científicos e ingenieros de Perseverance, con Plaza Sésamo y mucho más. Te esperamos.
Gracias, Diana. And don't forget, we want to see how you are watching the landing today. Use the hashtag Countdown to Mars to send us your photos and videos. To preview what interviews are coming up is my co-host from the JPL News office, Marina Jurica.
Thanks so much, Raquel. The excitement is building behind me right here in Mission Control as we count down to the Perseverance landing. We will be talking to some of the many people who made today possible, from scientists to engineers on the Mars 2020 Perseverance rover team to folks from NASA headquarters giving us a look into the future of Mars exploration. A little later, we will also be speaking with the students who named the rover and the helicopter. Inspirational stories as we prepare for another landing on the red planet. Back to you, Raquel.
Thanks, Marina. Let's give a shout out to the students around the nation learning about Perseverance's mission to Mars with their teachers. We are happy you're with us on this exciting day. Later in the show, we will be answering some of the questions you submitted through your classrooms. Landing on Mars is complex. The team will be calling out milestones as they happen. It's fast-paced, and you'll hear lots of technical terms. To help us translate and explain what is going on in Mission Control is Swati Mohan. She is part of Perseverance's landing team. Thanks for guiding us through landing today, Swati.
Hi, Raquel. I'm happy to be here today.
So, Swati, what is the status of the Perseverance rover right now?
So Perseverance is still in space right now, about 9,000 miles from Mars. So far, she is healthy and on course.
And it takes time to send signals between Earth and Mars. Can you let us know how that affects the information you are seeing?
So Mars is about 127 million miles from Earth right now. That means it takes about 11 minutes from light to travel from Mars to Earth. So all the information that we receive from Perseverance actually happened 11 minutes ago. So the round trip is 22 minutes for us to send a command to Perseverance and hear back on the ground that she's received that command. This is what we call two-way light time.
That's good to know. And can you tell us who else is in the room with you right now?
The operations team is split into 2 different areas. Here in the cruise mission support area, we have primarily the team that has been flying Perseverance from Earth to Mars. You'll see the placards with the roles of each of the people by their stations. Some of the people you may hear talking today are the flight director, who is the conductor of our operations orchestra here, the entry, descent, and landing activity lead, who is a member of the landing team tasked with understanding the execution of entry, descent, and landing, and then also the telecommunications and entry, descent, and landing communications engineers who will be monitoring the signal from Perseverance through the different paths that we have. Upstairs, in what we call the war room, we have almost the entire entry, descent, and landing operations team. And then across the hall from them, we have the surface mission control room, where the surface operations team is ready and waiting to take over as soon as Perseverance's wheels touch the ground.
And you have been part of this mission for years now. Can you tell us what have you been working on?
I've been working on Perseverance for almost 8 years now as a guidance, navigation, and control engineer, working primarily on entry, descent, and landing. One of my big tasks was to help with terrain relative navigation. Perseverance will be the first mission to fly terrain relative navigation. So while she's descending on the parachute, she'll actually be looking at the ground with a camera, seeing where she is with respect to the Martian surface, and choosing a safe spot to land that she can get to. After so many years of working on the mission, it's an honor to be here today as the mission commentator.
We're happy to have you here. Thanks, Swati. We'll be checking back in with you in just a few minutes as Perseverance approaches its next milestone.
Sounds good.
But for now, let's learn more about the rover's mission once it lands on Mars.
You know, Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled, the crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
You are watching live Mars landing commentary, and Perseverance is about to reach another important milestone. Swati, can you tell us what is happening?
We are at a milestone where the operations team determines whether they're ready to turn off the transmitter to Perseverance. Turning off the transmitter is like taking your hands off of the wheel. At this point forward, Perseverance would be on her own to execute entry, descent, and landing over 500,000 lines of code. Let's listen in.
Okay, all stations, we are ready for the transmitter off pole. ACS, are you go? ACS, are you go?
ACS is go.
Phase 2.
Phase 2 is go.
Activity. Activity is go. Uplink lead.
Go.
Systems. EDL com.
Go.
Telecom 1.
Go.
Telecom 2.
Telecoms go.
GDS 1.
Go.
GDS 2.
Go.
Fault protection.
Go.
Power.
Go.
Avionics.
Go.
Thermal.
Go.
Flight software.
Flight software go.
Data management.
Go.
Propulsion.
Go.
Art lead.
Go.
Team chief.
Go.
ACE.
Go.
Launch cruise phase lead.
Go.
Deputy mission.
Go.
EDL phase lead.
Go.
Mission assurance.
Mission assurance is go.
Chief engineer.
Chief is go.
Project manager.
Projects go.
Mission manager. All stations are go for transmitter off.
Copy flight, go for transmitter off.
There you have it, Raquel. We have deemed Perseverance ready to execute entry, descent, and landing on her own.
Thank you, Swati. As we just heard, Perseverance is now operating on its own as it cruises closer to Mars. To help explain what this mission means for the agency is NASA's Associate Administrator, Thomas Zurbuchen. Thomas, this is our 5th rover sent to Mars since 1997. Can you tell us how Perseverance is going to kickstart a new era?
Wow, this is such an important day today, and it really is the beginning of a new era in a sense that we're going from exploration, kind of with experiments on rovers, looking around, doing analysis, to the sample return phase, in which we're not only looking around, looking at the geology, but really turning our rover into a robotic geologist and astrobiologist, collecting samples that we will bring back to Earth. And for us, of course, those are where the best laboratories are of all of humanity. Some of them still remain to be explored by some that are not yet in the science community yet. And that's what we're looking forward to. It's that new phase. The other element that I want to talk about is the amazing technologies that are there. And of course, one of my favorites is the Ingenuity helicopter, this in search of this extraterrestrial Wright brothers moment, controlled flight for the first time elsewhere, Raquel.
Great. And we have a student question on video for you from Macy.
Hi, my name is Macy Ragsdale. My question is anything alive on Mars? Thank you.
Well, Macy, I'm so glad for your question. That's a question I ask myself. Is anything alive there? And frankly, at the surface where we're going right now with Perseverance, we do not believe there's anything alive right there because of the radiation that's there. It's chilling cold and there's really no water there. But guess what? We think that 3 billion years ago, this looked like a stream that you may see on Earth. And frankly, a lot more similar than Earth, with water with a magnetic field, just like the Earth with an atmosphere. And the question is, at that time, 3 billion years ago, were there single-cell organisms, just of the type that developed on Earth? So is there life on Mars overall? We don't know, but where we're going right now, we're really looking for ancient life, and that's what we're so excited about.
Thank you for your time today, Thomas. And thanks to everyone who has been using the hashtag Countdown to Mars. Here are some of the photos that you've sent in so far. Let's take a look. Now, please keep sharing with us how you are watching this moment today. For now, let's go back to Swati for an important update to what's going on in Mission Control as we get closer to another milestone.
Hi, Raquel. This next milestone is a communications pole. So during landing, not only will Perseverance talk directly to Earth, but we'll also be talking to two spacecraft that are currently orbiting Mars, the Mars Reconnaissance Orbiter and the MAVEN spacecraft. This poll is to confirm with the Mars Reconnaissance Orbiter spacecraft and the MAVEN spacecraft teams that they are ready and on track to support the relay from Perseverance. Let's listen in.
EDL comm flight.
Go flight.
Have you performed the comm check and readiness of the orbiters?
We have performed the voice check and the readiness poll and can confirm that MRO, MAVEN, EDA, Radio Science 1 and 2, UHF, DTE, DSN, and EDL GDS are all ready to support.
Copy, EDL comm.
So we've just heard that we have confirmation from each of the different orbiters and all of their support equipment on the ground that they are ready and are on track to support the relay from Perseverance.
Great, thank you, Swati. And we just heard that communications readiness poll, which means we are ready to relay the data Perseverance will send to get a better idea of what the rover looks like as it approaches Mars. We have a NASA program called EYES. The visualization lets anyone watching track Perseverance. Here's how the program works.
Follow Perseverance on its journey to the surface of the red planet with eyes on the solar system. From your desktop or mobile device, go to eyes.nasa.gov. Click on the banner, and now you're with Perseverance in real time through every step of EDL, entry, descent, and landing. This interactive experience lets you ride along from whatever perspective you choose. Click and drag, scroll in, scroll out. Check out the descriptions and explanations to increase your EDL expertise. Experience every entry, descent, and landing event precisely designed and executed to land Perseverance safely on Mars. The EYES experience is based on predictive data, but during this broadcast you'll see a different visualization called Ranger, and it's based on the real communication the team in Mission Control receives from Perseverance in near real time. This is the visualization the team will follow as data fills their screens while monitoring the health of Perseverance on its nerve-wracking course to another successful Mars landing. Enjoy the ride.
You are watching live Mars landing commentary. Stepping outside Mission Control to talk to us is Perseverance system engineer, Matt Smith. Thanks for joining us today, Matt.
Hey, Raquel.
Well, coming from Mission Control, we are going to hear terms related to landing. Can you help us understand what some of them mean?
Sure, definitely. One thing you'll hear a lot about is telemetry. So telemetry is just our way of talking about data that's coming from the spacecraft and telling us important things like temperatures on the vehicle, pressure, how much fuel we have left, and other things that we need to understand for the health and safety of the vehicle. You'll also hear the word nominal, hopefully. Nominal means everything is expected, everything is okay, we're good to go. You'll hear also a lot about velocity and deceleration. So velocity is just our speed combined with the direction we're going. And deceleration is our slowing velocity. So we're coming in at over 12,000 miles per hour, and we're going to slow down to a nice, comfortable 2 miles per hour at landing, and that's our deceleration. Speaking of landing, you may hear a couple important terms at landing itself. One is RIMU stable. So the RIMU is a device on the rover that measures the rover's orientation and whether it's moving. So we want a nice, stable landing spot without any motion. You'll also hear UHF stable, hopefully. UHF stable refers to good telecommunications link with the rover and indicates that we've had a good separation between the descent stage and the rover after the sky crane maneuver. Finally, you may also hear Tango Delta nominal, or touchdown nominal. That means we've touched down on the surface of Mars within the expected range of safe landing speeds.
Thanks for that breakdown. Now, this is your first Mars mission. What have you learned from this experience?
Yeah, one of my takeaways is that you can almost never be too careful when it comes to Mars. You definitely can't take Mars for granted. You know, we've checked and double-checked and triple-checked everything on our way to Mars. And, you know, even though we've done this once before using the sky crane technique on the Curiosity rover, you know, I think everyone's going to have everyone's going to hold their breath until we're on the surface of Mars this time around.
And we have a social media question coming in. Nor the Door on Instagram asks, how complicated is the automated landing sequence and who wrote the code?
Yeah, it's quite complicated. The automated landing software needs to do literally hundreds of things all on its own, just right with sub-second timing accuracy. And it's the result of many hundreds of people over many years, stretching all the way back to Curiosity and then improved for the Perseverance landing today at Jezero Crater.
Great. Thanks for your time today, Matt, and good luck.
Thanks.
Now, landing on Mars is hard. Landing on Mars during a pandemic is even harder. The team behind the Perseverance rover faced one of its biggest challenges when the coronavirus pandemic struck. Here's how they kept the mission going.
When the pandemic struck, the future was certainly unknown. It was like walking into a blind, dark alley. You didn't know what was there, what was in front of you, what you were going to have to deal with.
It's something that nobody expected. It's something that nobody could plan for.
So we all were asked to start working from home.
Rather than your first priority being mission success and getting to the launch pad, your first priority immediately gets displaced, and it's now the safety of the people.
And it took a lot of work to put stuff together in order to keep momentum going, to keep people working safely, keep them healthy, and to keep the project on schedule.
We called the effort Mars 2020 Safe at Work, and the objective was to keep the team as safe or safer than they would be if they were not working. You know, putting a spacecraft together that's going to Mars and not making a mistake, it's hard no matter what. Trying to do it during the middle of a pandemic, it's a lot harder.
And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
Certainly never done something like this before. Try to lead a team that's flying a spacecraft on the way to Mars while getting ready for landing, while doing it all from home.
There's no doubt that working in isolation, not virtual isolation, but in physical isolation from everyone else, is a challenge.
We had to rethink and redesign what it meant to operate a spacecraft in flight when we couldn't all be in the same room in mission control, seeing the data come down from Perseverance.
It was a major change going to that, you know, looking at everyone on a screen instead of in person.
Because of the pandemic, you can't you know, just pop over your cubicle wall and talk to the person next to you.
It's definitely been a challenge to figure out how to communicate and get everything done remotely, but we've managed to make it work.
We are explorers. Our job is to go into the unknown, and this is just another example of the unknown.
We're really doing something that's transformative and trying to understand whether or not life evolved on another planet. That's the fundamental objective of this mission.
We're all still connected by this incredible mission and this this wonderful team that we have the opportunity to be a part of. So that keeps at least me going.
Pretty much everybody that I've talked to that's associated with the mission has said the same thing, which is you could not have come up with a better name than Perseverance.
It's an amazing serendipity that we get to persevere through working on Perseverance.
Joining us now is Perseverance Deputy Project Manager Matt Wallace. Matt, just how ambitious is this mission, and how was the Perseverance team able to stay on track with unexpected challenges like the pandemic?
Well, it's a very ambitious mission. You know, we're carrying not only a host of new, extremely capable science instruments to do that science mission that we've talked about, but also a number of technology experiments that will provide feed-forward information into the next set of robotic explorers or even human exploration of Mars. So there's a lot for us to do. We look a lot like Curiosity, but in fact we're carrying 50% more payload down to the surface of Mars. And so it's been a big challenge. You know, and it was particularly challenging when the pandemic struck. It came at a critical time in our processing. We were just months away from launching. We were trying to essentially get the spacecraft assembled and do the final tests. We did not have a lot of margin in our schedule, and our focus just entirely shifted from that to keeping the team safe and keeping their families safe. And we had to do that quickly. We had to make that adjustment quickly. I think, you know, we got through it with a lot of help. A lot of people stepped up to make it happen. The team was tenacious, and we managed to get it launched and fly it to Mars. You know, thanks to a lot of help.
And Matt, just how large is the team that worked on Perseverance?
It's a big team. A couple thousand people here just at JPL, in fact, have worked on this mission. And then almost every other NASA center has contributed in some significant and critical way as well. We have over 1,000 industry partners that have provided hardware into this mission from 44 different states, 560 different cities. And of course, we have international contributions from Europe and many other international providers as well. So it's a big team. It's taken a lot of people to get us to where we're at.
That is a big team. Yeah. This is the most difficult landing site ever attempted. Now, why do you think Perseverance is ready to land in Jezero Crater now?
Jezero is tough. I mean, it's scientifically fascinating because it's got a lot of things like craters and you know, rock fields and cliffs and sand dunes and that sort of thing, which are great for the science community. That's exactly the type of features they're looking for to learn more about Mars. But they're all landing hazards for us. And so we've had to add some new technology, terrain relative navigation, which is the ability essentially to divert away from hazards. But we have taken this system through the same types of paces that we have on previous missions. We've used the same techniques, the same best practices for engineering verification, and in many cases, we've used the same people. This, in fact, is my fifth Mars rover mission, and I'm not alone. There's other people on the project in the same situation. So, you know, the team has given it everything they've gotten to put it all out there and to make this successful, and I think we're ready.
Thanks, Matt, and good luck on your fifth mission.
Thank you very much.
Well, Jezero Crater is a location on Mars that has intrigued scientists for years. Let's head over to Marina to learn more about the science goals of the mission.
That's right, Raquel. Here to explain why we want to go there is Deputy Project Scientist Katie Stack Morgan. Welcome, Katie.
Thanks, Marina. Glad to be here.
Now, Perseverance is landing on Mars at the Jezero Crater. Why is it that you and the team chose this particular area?
Yeah, so scientists believe that Jezero Crater is one of the best places on Mars and possibly the entire solar system to look for signs of ancient life. Jezero contained an ancient lake and has within it one of the best preserved ancient delta deposits on the surface of Mars. And deltas form when a river enters a relatively open body of water, like an impact crater, and deposits the sediment that it's carrying into the lake. And we know based on studies of deltas and lakes here on Earth that they're great places to concentrate and preserve organics and support microbial life. We're also excited because Jezero exposes rocks that are between 3.5 to more than 4 billion years old and represent a variety of different geological processes.
Now, this might be a tough choice, but what do you think would be the most rewarding scientific discovery that we expect to get from this mission?
Yes, hands down, I think the most rewarding discovery I think we could make with Perseverance would be finding a truly compelling ancient biosignature on Mars. The rocks in and around Jezero Crater record a period of time when life first arose in the solar system, and we have the opportunity with Perseverance to study the evolution of a planet from a once habitable world likely capable of supporting ancient life to the cold, barren planet we know Mars is today.
And why do you think, Katie, it's so important to find out if there really is or was ancient life on Mars?
Well, the question of whether there's life beyond Earth is one of the most fundamental and essential questions we can ask. And our ability to ask this question and develop the scientific investigations and technology to answer it is one of the things that make us as a species so unique. And based on everything we know about Mars in the past, it absolutely should have been capable of supporting ancient life. So we can find out an answer to the question, where there were habitable environments, was there life? And studying the possible emergence of life on ancient Mars can also help us better understand the conditions that led to life on our own planet Earth.
That's so fascinating, Katie. And now we're going to take a question from a student, Vara.
Hi, I am Vara, and my question is, why was Mars able to sustain lakes and rivers ages ago, but cannot now? Isn't it cold enough to make water, and isn't it always? Thank you.
Yeah, that is such a great question. And one of the things that protects our atmosphere here on Earth and allows liquid water to be stable on our own planet is the fact that we have a magnetic field protecting that atmosphere. We think that Mars lost its magnetic field way back billions of years ago and left the atmosphere exposed to things like solar wind and cosmic rays that basically blew that atmosphere away. And once that happened, liquid water wasn't stable on the surface of Mars anymore. It was too cold and the pressure was too low. And so now Mars is not capable of supporting liquid water and likely not capable of supporting life at its surface.
Well, thank you so much to Vara for that great question. And a big shout out to all the kids that are watching out there today. And thank you so much to you, Katie, for joining us. That was so great.
Thank you.
Now sending it back over to you, Raquel.
Thanks, Marina. Earlier, we were able to catch up with the communications systems engineer, Chloe Sakier. She helps us break down the system used to track Perseverance during landing.
The communications infrastructure supporting Perseverance's landing is quite complex. We've rallied a truly global network of relay and communications assets to help us capture and record those precious minutes of entry, descent, and landing, or EDL. We receive a stream of engineering telemetry via these communication assets that helps us see and understand exactly what's happening. Perseverance sends direct-to-Earth X-band tones, each of which provides us with indications of critical entry, descent, and landing events. During entry, descent, and landing, we have 2 Mars orbiters listening for the ultra-high frequency, or UHF, signals from Perseverance. These orbiters relay these signals to deep space network stations on Earth, Madrid in Spain, and Goldstone in California. The Mars Reconnaissance Orbiter, or MRO, has reconfigured its software to perform a type of relay called bent pipe. This will provide us with near real-time telemetry during entry, descent, and landing. We have coverage from the Mars Reconnaissance Orbiter from just before entry to a few minutes after landing. The telemetry we receive will be delayed by the time it takes light to travel from Mars to us back on Earth. Additionally, the Mars Atmosphere and Volatile Evolution spacecraft, or MAVEN, is recording these UHF signals and will be relaying that recording hours after landing. MAVEN will be covering us from around the time of cruise stage separation until a few minutes after landing. We also receive what we call heartbeat tones, which are indications that the spacecraft is alive and progressing throughout entry, descent, and landing. It's important to note that while unexpected, we could lose our communication links and still land safely. Because Perseverance is doing entry, descent, and landing completely autonomously, she doesn't need our help to joystick the landing. The communication links give us added visibility.
And you can see Chloe hard at work inside Mission Control right now. Perseverance's landing might look like the system the Curiosity rover used back in 2012. But landing on Mars is difficult. There's always a risk involved. Here's what needs to happen for Perseverance to touch down safely in Jezero Crater.
Nothing can be taken for granted when you get to Mars. There's a lot of things we just don't know.
Space always has a way of throwing us curveballs and surprising us.
I mean, until we get the data that says we're on the ground safely, I'm going to be worried that we're not going to make it.
Entry, descent, and landing is often referred to as the 7 minutes of terror because it takes about 7 minutes to get from the top of the atmosphere of Mars to the ground safely.
The spacecraft has to do all of this by itself.
There are many things that have to go right to get Perseverance onto the ground safely.
There's a lot counting on this. This is the first leg of our sample return relay race. There's a lot of work on the line.
Starting about 10 minutes before atmospheric entry, we get rid of really the spacecraft part of the rover that's been supporting us.
We come screaming in to the Martian atmosphere at 12 to 13,000 miles per hour.
And the heat shield is what dissipates all that initial energy through friction.
The vehicle will continue actually flying itself through the atmosphere. It's sort of like a transforming vehicle that went from a spacecraft, and now it's kind of like an aircraft actively guiding itself.
When we're going slow enough, we deploy a parachute.
It's the biggest supersonic parachute we've ever sent to another planet. It's critical for slowing down the vehicle.
Perseverance's entry, descent, and landing borrows heavily from that of Curiosity.
But fundamentally, Perseverance is a different rover. She's bigger, she has different instruments.
We've added a lot of smarts on the inside to make it more capable so that it can deal with the landing site that we've given it.
The science team identified Jezero Crater as basically an ancient lake bed and one of the most promising places to look for evidence of ancient microbial life and to collect samples for future return to Earth. The problem is it's a much more hazardous place to land.
When you look at Jezero, all you see is danger. How do we go to a site that we never thought was safe enough to go to before? So the heat shield, which has protected us all the way through entry, is no longer necessary. We need to get that off so that we can actually see the ground. And we can see the ground in a couple different ways.
Perseverance will be the first mission to use terrain relative navigation. So while it's descending on the parachute, it will actually be taking images of the surface of Mars and determining where to go based on what it sees. This is finally like landing with your eyes open. Having this new technology really allows Perseverance to land in much more challenging terrain than Curiosity or any previous Mars mission could. Amongst the rocks and the craters and the cliffs, these things are hazardous to the rover, but these are the things that are interesting to the scientists.
Once Perseverance has figured out where she is, we jettison the back shell and parachute and light up our rockets. Those rockets help us steer to a safe landing spot that's nearby.
That descent stage takes us all the way down to about 20 meters off the ground.
That's when we start the sky crane maneuver. And once the rover has hit the ground, the descent stage will cut loose from the rover and fly away to a safe distance. Surviving that 7 minutes is really just the beginning for Perseverance. Its job, right, being the first leg of sample return, to go look for those signs of past life on Mars. All that can't start until we get Perseverance safely to the ground. And then that's when the real mission begins.
With us now is Al Chen. He is Perseverance's entry, descent, and landing lead. Al, you were part of the Curiosity rover landing. Does it get any easier the second time around?
It absolutely does not, especially when considering we're trying to land the biggest, heaviest, and most complex rover we've ever built at the most dangerous landing site we've ever attempted. Jezero may look great and promising from a science perspective, but it's absolutely treacherous for landing. There's a cliff wall that's about 200 feet tall that runs right through the middle of the landing site. There are craters full of sand that even if we landed in them, we would not be able to drive out of. And there are rocks to the east and actually all over the place, and rock fields. That would be a bad day for us if we were to land on them.
Now, Al, what new technology makes this type of dangerous landing possible?
Perseverance is carrying two new technologies that are really kind of under the hood smarts that are allowing us to land at this kind of treacherous landing site. The first is range trigger. That's the ability, we've given Perseverance the ability to decide for herself, based on where she is, when to deploy the parachute. Previously, we used to deploy parachutes, that supersonic parachute, based just on navigated velocity. But now Perseverance has the smarts to figure out where she is and deploy that parachute at just the right place to make sure that we shrink where we could come down. That actually reduces the area, that error ellipse, where we can come down on the ground, from something that was on the order of 15 miles long by 12 miles wide for Curiosity to about 5 miles long by 4 miles wide for Perseverance. So that's quite a bit of reduction. Second, the next piece of technology that's helping us land there is terrain relative navigation. In the past, after we've popped off the heat shield, we've taken pictures of the ground as it's been coming up, but we haven't really done anything with them. This time, Perseverance is carrying a camera to take pictures, but also a kind of second brain to help it figure out what those pictures are telling it and match it up with an onboard map from a satellite. That allows it to figure out exactly where she is. Suddenly then, she can then fly to safe spots that are nearby once she really knows where she is. It allows the site to not have to be as flat and boring as a pancake as some of our past sites have been, the entire area we could come down. Now we just need little pieces of that site to be small enough and safe enough for us to land in safely and fly there after we've gotten rid of the parachute.
And we also have a social media question coming in. Sansakari14 on Instagram is asking, how does the Sky Crane decide where to move itself after the payload lands?
After the payload lands, after the rover touches down, the Sky Crane, the descent stage, which is that rocket-powered jetpack above it, the first job, of course, is to make sure you don't hurt the rover. So it'll turn forward or backward so that the engine plumes don't pass over the rover. So it'll come up and start to turn. And it'll go in whichever direction is closest to north. So it can either go forward, if that's the way north is, or go toward the rear of the rover, if that's where north is. And it'll fly about 1/3 of a mile or so away.
Thanks for talking to us today, Al.
Thank you very much.
Now, let's head back to Mission Control for an update from Swati.
Hi, Raquel. So remember that command that we sent at around 11:35 to turn the transmitter off? We are just about to get confirmation that Perseverance has received the command. The command took 11 minutes to go to Perseverance, and then the reply took 11 minutes to get back from Perseverance to the ground. So we should hear about any second now that we have officially turned off the transmitter. And after that, we will be about 4 minutes from the start of entry, descent, and landing mode. At this point, we will transition from the cruise approach mode to entry, descent, and landing. And that means our travel from Earth to Mars is done, and now we just need to get to the surface. So far, things are looking good.
Great.
Oval, this is TAD 3, ready to show estimated miss distance for OD 132.
Copy EDL phase, welcome back.
Go ahead.
Flight Ace. Go Ace. Our tracking stations have all confirmed the results of the transmitter drive-off and in lock one way. Copy Ace. GDS flight. Flight GDS. At this time, I'd like to disable the alarms before EDL main. So please disable all the alarm files and start a new downlink session. Copy that. EDP. Copy that. Proceeding now.
Confirmation that we are now officially one way and the transmitter is off.
Rover mission has helped shape the other starting with the landing of the Pathfinder more than 20 years ago, leading up to where we are today with Perseverance. Perseverance Deputy Project Manager Jennifer Trosper has worked on every Mars rover mission, and she joins us now. Jennifer, how does Perseverance fit into the history of exploring Mars?
Thanks, Raquel. It's great to be here. Well, Perseverance is NASA's 5th rover on Mars, and I've had the privilege of working on every one of them. And the very first rover was the Sojourner rover we sent in 1997, and it was the size of a microwave oven. And even at that small size, Sojourner was able to transform the way that we explore Mars, from stationary landers to small roving robots that go from place to place, just like a geologist would on Earth. So once we had that roving capability, then we sent our twin rovers Spirit and Opportunity. Spirit and Opportunity were tasked with finding evidence of ancient water on Mars. Now they did. They're great explorers, and both of them found ample evidence that water had once existed on the surface of Mars. But we had a question. Another question then was Mars ever habitable if water had been there? And that's when we sent Curiosity. Now, Curiosity was a major upgrade to our rover fleet. She's the size of a small car. She landed with the Sky Crane system instead of airbags. And she also carries along her own sample analytics lab, and she's still operating today. And during her exploration, she has found evidence of a habitable environment in an ancient lake bed on Mars. So now we're sending Perseverance. Perseverance is tasked with answering the question and looking for evidence of ancient microbial life on Mars. And in order to do this, she has to be the smartest and most capable rover we've ever sent.
Speaking of Perseverance, can you tell us more about how Perseverance is smarter than its predecessors?
Yes, we've made a lot of upgrades to help her along with the surface mission. One of them is for her autonomous traverse capability. When I say autonomous traverse, I mean we tell her where we want her to end up, and she has to figure out the safe and best way to get there. In order to do that, she uses her cameras, algorithms, a computer. So we've given her another computer, we've upgraded the cameras, and we've upgraded the algorithms. Now she drives 3 times as fast as Curiosity could drive in this autonomous traverse mode. In fact, her average daily distance for driving, about 200 meters, is close to the maximum distance any rover has ever driven in a day on Mars. So she's fast. Another thing that we've done, which is the most significant upgrade that we've made, is the sample caching system itself. Curiosity has a robotic arm, like Perseverance has a robotic arm, but on the end of Perseverance's robotic arm is a coring drill that will go and take rock cores, transfer them into sample tubes and into the rover, where another robotic arm will take those tubes, will seal them and store them, and eventually drop them on the surface of Mars for future return to Earth.
Great, and we also have a social media question about Perseverance. Erica AS on Instagram wants to know what the wheels of the rover are made out of.
Great question. Well, you may think we make them out of some material you've never heard of. It turns out they're made of aluminum. Now, Perseverance's wheels are a little thicker than Curiosity's, but they're actually both made out of aluminum.
And one more question for you. Can you tell us more about the importance of where you are right now in the building?
Yes, I am above, on the 2nd floor, above the cruise mission support area that you've been watching. And this is the surface mission support area. So as soon as Perseverance lands, all commands, this room will take over. It will become headquarters for operating Perseverance on Mars.
Thanks for taking the time to talk to us today, Jennifer.
Thank you.
Now, we now know Perseverance's place in history. Let's take an up-close look at the rover with Mars 2020 System Testbed Engineer Elio Morillo.
Thank you, Raquel. I'm standing in front of the Mars 2020 Perseverance scaled model. As you can tell, this vehicle is about the size of a Mini Cooper. These wheels are obviously black here and they look like rubber, but they're actually fully made of metal. These wheels are designed to allow us to climb over obstacles and of course climb over hills and minimize the amount of slipping once we're traversing on the surface of Mars. Here in the front of the rover, we have the sample caching system. And of course, at the very front end of this is the robotic arm, which this entire system is arguably the most complex robotic system we've ever sent outside of Earth. Here at the tip of the arm, we have a turret which contains a suite of instruments along with some drills and coring capabilities that will allow us to do contact science once we get to the surface of Mars. Not only that, this robotic system is equipped to collect samples about the size of a piece of chalk that then eventually will be stored inside of the vehicle and dropped off in a later location so that an eventual mission can go and return these samples to Earth, something we've never done in the past. Here in the front, we have the remote sensing mast. Something of note is that this mechanism is going to be stowed upon the touchdown on the surface of Mars. And one of the first critical activities we do is deploy this mechanism. This mechanism includes several cameras that are going to give us some of the most breathtaking images we've ever taken on Mars. Along with that, we have some lasers as well as a spectrometer. They're going to allow us to do some remote science. Here you see some of these extrusions that are part of the larger weather suite of instruments that will allow us to characterize the local climate around Perseverance. So that's a quick tour of the rover, but I gotta get back to work. So back to you.
Perseverance is collecting samples of Martian rock for future return to Earth. We've heard that scientists have been wanting to bring Martian samples back for many generations. And here to talk a little bit about that is NASA's Planetary Science Division Director, Lori Glaze, who joins us now to talk about the role Perseverance will play in NASA's future goals. Welcome, Lori.
Hi.
Now, as you just heard, we've heard that scientists have been wanting to bring back these Martian samples for a very long time. Why do we need to bring them back?
That's really a great question. You know, we actually have examples of Mars already here on Earth that came here as meteorites. But we don't know exactly where they came from on Mars, and then they also have had to make the trip from Mars to Earth, and so they got altered during that time, and then during their entry and descent into the Earth's atmosphere, that also changes what those rocks are like. So being able to go to Mars and actually collect a sample where we know exactly where it came from, and we know we can preserve it and keep it pristine and carry it all the way back here, this will be incredibly important to help us answer questions about the geologic history of Mars, understanding how it formed and evolved, and also really important questions about whether or not life actually existed on Mars 3.5 billion years ago, and whether that life, if it existed, has been preserved in the surface of Mars.
Now, Lori, these sample tubes that Perseverance is going to be collecting, they're the cleanest things ever created on Earth. Tell me a little bit about that.
Oh my goodness. We worked so hard. The team here at JPL is absolutely incredible to assure that those sample tubes are incredibly clean. One of the main goals of this mission is to be able to detect if there's actual life that's preserved, ancient life preserved in those rocks, in those samples. And we definitely don't want to be carrying, our own DNA off to Mars and then bring it back here to confuse our scientists when they're trying to study those samples. So it is an incredibly clean set of equipment that's been sent there. As you said, the cleanest thing we've ever sent into space.
Now, this is a very complicated campaign. Can you break down for us how it's going to work and if there's any international partners working with us?
You are correct. The Mars Sample Return campaign is incredibly complex. In fact, it's probably the most challenging thing we've ever tried to do. But we're definitely not going to try and do it alone. We have great partners with the European Space Agency. And the way this campaign is going to work, well, Perseverance is the first step. Chapter 1 is going to Mars and collecting the samples. Chapter 2 is going to be a sample return lander that we hope to launch in around 2026 to 2028. And that lander, it'll be an American lander carrying a fetch rover that's provided by European Space Agency. And that little fetch rover will drive out and pick up the samples that Perseverance left on the surface of Mars. and the Fetch rover will bring them back and load them into a rocket that we call the Mars Ascent Vehicle, which will be the first ever launch from another planet, and it will launch those samples into orbit around Mars. In the meantime, the European Space Agency will have an orbiter that's in orbit around Mars that can rendezvous and capture those samples and then bring them back to Earth for us to study back here in our amazing laboratories.
A lot of firsts, it sounds like, Lori. And another first, how is Perseverance and the Mars Sample Return mission going to help the future exploration, human exploration of Mars?
I'm so glad you asked that. I think we're going to get a lot of great information from Mars Sample Return with, again, being able to land the heaviest payload we've ever landed on Mars will be that Sample Return lander. That's critical to us learning how to land humans on Mars. And then we are definitely going to want to be able to launch the humans back off of Mars. So that Mars Ascent Vehicle is going to be critical, that first step of the first launch from another planet.
So exciting, Lori. And speaking about the Mars generation, we're now going to take a student question for you from Livia.
Hi, my name is Livia, and my question is, what made you want to study Mars, and why are you working so hard and willing to wait so long for a sample? Thank you.
Oh, Olivia, that is such a great question. And I enjoy Mars just because it can tell us so much about how our solar system formed and evolved. All of the planets can tell us different parts of that story, and Mars is a really key piece of that. And one of the main reasons we're willing to wait so long to get the sample back is that we've got great new scientists that are all about your age, and in about 10 or 15 or 20 years, you'll be the generation that's going to actually get to work with these samples. When they come back, you'll be the scientists and engineers that will be the next generation to change how we think about Mars and how we think about life in the solar system.
That was a great question, Lori. Reach for the stars, future little scientists and engineers. Thank you so much for joining us here today, Lori.
It's my pleasure. Thanks.
Back to you, Raquel, for another mission update.
Thanks, Marina. The cruise team for Perseverance controls the rover on its way to Mars. And moments ago, they handed it over to the landing team, and it looks like team leaders in Mission Control are about to talk to both teams. So let's listen in.
The CBM change, as I mentioned previously, is to the EDL reserve two-way non-coherent route.
Activity.
Copy flight.
EDL phase, go ahead.
I'd like to see pep talk, I guess, to the team. All right. I'm terrible at pep talks. I think my reputation precedes me there. And look, I know this hasn't been easy, right? I'm not even sure we've even been all in the same room at the same time. I mean, I'm staring at folks across the internet as well. Even now, right? Only. Yeah. Voice check. Okay. I do want to just extend my heartfelt appreciation from the EDL team to the launch cruise team. You've done everything we've asked for, right? I mean, you've battled anomalies, you've dealt with SETIs, you've done everything. You delivered a healthy spacecraft to the place that we want to go, and she's right on target, right? We did the last maneuver literally 2 months ago, right? This is pretty incredible, in my opinion. And she's armed with the right information to help us land. Doing the parameter update last night, we're ready to roll. You've done everything right. And you've put up with us too, right? You've put up with our eccentricities and the things we like to do in EDL land. So I very much appreciate that. So you all should sleep in on Friday, since you guys have earned it. Thanks for literally and figuratively putting us in the right position to succeed. And let's land on Mars together.
Copy EDL phase. And as flight director, I also would like to thank the whole team, cruise ops, EDL ops, EDL team, and the surface ops as well. It's been an amazing journey. I think we all know that. And it's been my honor and pleasure to work with you all side by side. And your tireless efforts and endurance in the face of our challenges has been truly, truly inspiring. So kudos to you. Mission, would you like to say something?
Yeah, just echoing the same words that Al and Magdi have mentioned. You guys have overcome great obstacles in the last 6.5 months, and it started with an earthquake in this room on launch day at L-20 minutes. So I can't be more proud than all of the achievements that you guys have pulled off in the last 6.5 months. Whatever happens in the next hour and a half, you can be proud of the achievements that you've accomplished so far. I look forward to seeing you on the other side, and I only wish that the rest of our team could be sharing this moment with us. This is a very unusual event. This room is only half as full as it would be if we weren't in this pandemic. So missing everybody on the team who's not with us here today. And go EDL.
Welcome to the EDL family.
And with that, Godspeed Perseverance. All right, activity. Go ahead and continue the report.
Sure thing, Flight. We've since completed the EDL Start Anchor. As I was mentioning, we changed our CBM row to EDL Reserve two-way non-coherent. That row reinforces our CBM windows disabled, keeps our packetization on, it turns off our ranging and switches to the auxiliary oscillator. We have also started our real-time data products and reinforced Medley on. At this time,
Now, we just heard Perseverance team leaders thank the cruise team for their work in guiding the rover to Mars. Now, did you know the rover name and Mars helicopter name came from students? Well, a couple weeks ago, Marina was able to catch up with them.
Thanks, Raquel. Earlier this year, NASA and our partners held a nationwide essay contest to name our Mars rover. Alex Mather, a 7th grader from Springfield, Virginia, submitted the winning essay that was selected by NASA from a field of more than 28,000 entries from K through 12 students in every state in the U.S. Vanessa Rupani's essay for Ingenuity was so compelling, NASA thought it would be a perfect name for the history-making helicopter, a technology demonstration carried aboard the Perseverance rover. Alex and Vanessa join us now. Welcome, you guys.
Hello, space nerds.
Hi. Now, you got to go to Florida and watch the launch live back in July. Alex, what were you feeling as you saw that rocket launch into the sky?
I read a lot of books written by astronauts, and every single one of them always talks about the raw power behind the space launch. And I definitely feel like watching the launch invoked that sense of inspiration mixed with anticipation, along with that rumble in my chest.
That's very inspirational, and I'm sure that you have had many conversations with your classmates since this all began. Now, what kind of questions have they asked you?
I got some people asking me about what this helicopter is, what this rover is, what are they actually going to do. So I love that this whole experience sparked a greater interest in the mission in my community.
Why do you think it's so important for kids to be inspired by space exploration?
Because space is the future, and kids are the future. Learning about space and watching the story of humanity spread to the stars happen is watching the future happen and seeing history unfold.
The best way to keep our home safe and protect our planet is to learn from the worlds around it. So I think it's really important for the next generation of scientists to be engaged in that type of exploration to make our home the best place it can be.
Now, speaking of the future, what has your life been like since naming the rover and helicopter? Has it sparked any future aspirations for the two of you?
Oh man, I am currently applying to a science and technology school for high school. Hoping for a NASA internship sometime along the way, with my ultimate goal being to join the incredible team of scientists and engineers who are about to make this happen.
This whole experience has definitely shown me that I want to go into the space industry. I came home from Florida, did all my college applications, and checked aerospace engineering on all the boxes. I mean, the whole time we were there, I was thinking, why would anyone want to do anything else?
So true, and the best of luck to both of you. Thank you so much for joining us here today, Alex and Vanessa.
Thank you for having us.
Thank you so much. I had a great time.
Now, your essays, as well as the top 155 finalist essays, are riding on the Perseverance rover, along with nearly 11 million of the names from all over the world that were submitted before launch. And if you miss the chance to get your name on Perseverance, then you will get another chance to reserve a spot on the next mission to Mars. So make sure that you sign up now at mars.nasa.gov for your boarding pass. As virtual celebrations are happening all over the globe, let's take a look at some of your submissions on our social channels, showing us how you're celebrating the Perseverance landing right now. And remember to hashtag Countdown to Mars and send those in. We would love to show them off. Look at these kids. They are getting so excited. Everyone's watching it. A lot of classrooms are watching it. Oh, and great, someone did a Lego version of Perseverance, which is awesome. It looks fantastic. We love getting all your pictures out there. We've gotten a lot of artwork from kids, which has been great. I know I have a 9-year-old John at home, and he loves to draw the rover. And look at that. That is awesome. That's better than anything I could bake, that's for sure. Perseverance in a cake. That looks so great. Delicious. I want to get into that. Another great send-in from David Bowie Reel. Thank you so much for your submissions. Remember, hashtag Countdown to Mars. We love to see how you're celebrating. Now, you might know our next guest from shows like Emily's Wonder Lab. Joining me now is Emily Calandrelli. Thank you so much for being here with us today.
Hi, thanks so much for having me.
Now, you are very passionate about getting kids interested in science and space exploration. Why do you think kids are so excited about space?
Well, I know the reason I'm excited about space, and I think it's the same reason that many others are excited about space, and it's that the people in the space industry work to answer two of the biggest questions that humans have ever asked. Are we alone in the universe, and where did we all come from? And by sending a rover to Mars, we are gaining evidence for the answers to these questions, more evidence than we ever had before, and I think that's so exciting.
It is, and I know you get loads of interesting questions from kids. Have you gotten any about Mars specifically?
Oh my gosh, yes. Everybody loves Mars. It's in movies and books and TV shows, and everybody loves Mars. So one of the things that I get asked a lot is that, it's called the red planet. Why is it red? Well, it's red because it's literally rusty. The top layer of soil on Mars has iron oxide in it, or rust, and rust has that brownish red color. So it's red because it's rusty. And also because it's red, they ask, is it red hot? Is it really hot on Mars? And well, no, actually, it's colder than the Earth. It's farther away from the sun. So as you would imagine, it's a little bit colder than the Earth. It also has a really thin atmosphere. So the heat that it does have, it has a hard time keeping in. And so it's a little bit colder. But then I also get asked, what would I weigh on Mars? That's a really fun question. So on Mars, it's a little bit smaller than the Earth, so the gravity there is weaker. It's about 3/8 the gravity that we have here on Earth. So if you weighed 100 pounds here on Earth, you'd weigh 38 pounds on Mars, or 100 kilograms here on Earth, 38 kilograms on Mars.
Those are all super fun. I think even some adults want to know the answers to those questions, Emily. Now, why do you think it's so important to educate kids about science and give them that great foundation?
Well, science is the language of nature, and learning about science and learning how to think like a scientist means you are learning how to systematically seek out truth in the world. You are learning the scientific method, you're learning how to be a critical thinker, and honestly, those skills are great for whatever you end up wanting to do in life.
True. If you want to be a scientist or an opera singer, that holds true. And what are you most excited about today?
I mean, humans are launching a robot to Mars. That doesn't happen every day. I think in all of the hecticness that is going on today and all of the nerves, I just hope everyone can take a moment to sit back and remember that we live in a time when humans have the ability to send a robot to another planet. And that's so cool to me.
It is very cool, Emily. Take a deep breath. Thanks for joining us here.
Thanks for having me.
Sending it back to you now, Raquel.
Thanks, Marina. We are offering lots of ways to ride along with us to Mars. Now put yourself right into the action now with our Perseverance photo booth. You can pose next to the rover, place yourself in our mission control, and even see what you might look like taking a selfie on the Red Planet. There, you'll also have a chance to sign up to send your name to Mars on NASA's next flight to the Red Planet. It's all available at go.nasa.gov/Mars 2020 Toolkit. And joining us now is JPL Chief Engineer and landing veteran Rob Manning. He will be breaking down key moments coming up, and very few people know more about landing on Mars than Rob, going back to the Pathfinder mission in 1997. Thanks for joining us today, Rob.
Thank you very much, Raquel, for having me here. And what a wonderful experience. What a wonderful day for a beautiful day in California. We're just all so excited here, anxious, worried, but very hopeful.
Rob, I have a question for you. There is a landing tradition at JPL that involves eating peanuts for good luck. Can you tell us how did that start?
Yes, it started in the mid-1960s. What happened was we had a series of missions that had failures. The Ranger program in the early 1960s, one after another, failed. And what happened was one day, a fellow by the name of Dick Wallace on Ranger number 7, on the 7th attempt, decided to bring peanuts to the ops area just before the launch, and guess what? That mission worked. Now, we're not supposed to be too superstitious. We're engineers and scientists after all, but we love tradition. And ever since then, before launch and before critical events like entry, descent, landing, we have brought out peanuts and shared them with the team. And it's been really a wonderful little experience. And so this is something we'll do. We're doing right now. And it's something that we just can't help ourselves. It's just part of the experience.
Oh, well, speaking of the experience, how did the Perseverance team keep the tradition alive this year?
Well, this year we're passed out little packets of peanuts to the team, and they can sneak one peanut in their mouth to keep the tradition alive. But you know, this is part of the COVID experience, but we can't leave this one undone. So this is what we're doing, and this is going to help us land safely.
All right, thanks, Rob. I have some questions for you a little later on, but we're heading back to Swati Mohan, who is part of the landing team. She'll be calling out key milestone and events as they happen from Mission Control, so let's listen in right now.
So right now we're still about 20 minutes from entry, and the EDL phase is giving a last-minute confirmation of what will be happening in the upcoming changes to the vehicle, just to remind the team.
This will allow us to steer our trajectory as we make our way through the atmosphere. This is one of the things that allowed MSL, the Curiosity rover, to land where it did. And we're depending on the same type of entry guidance this time around to help get us very close to our target. As we make our way through entry, finish our guided entry profile, we'll do a maneuver called heading alignment, where we point toward the target and get ready to deploy the parachute. But before we deploy the parachute, we need to get rid of a set of balanced masses that have been giving us a center of gravity, or CG offset, throughout the guided entry phase. So these are called the entry balance masses. We also call this maneuver SUFR, S-U-F-R, or straighten up and fly right. So we'll go ahead and eject those masses when we get a trigger from the GNC system telling us that we're at the appropriate range to the target to do so. As soon as we deploy those, we will no longer have a CG offset, and we'll be ready to deploy the parachute 17 seconds later.
Right where the Perseverance team is sitting now, what's in store for them as we approach landing?
I'm going to hold here for EDL prep as we're about to start that anchor.
Copy, Phase 2. And activity, please call that out when it's ready. Copy, Flight.
I'm going to make the announcement now. Go ahead. Maggie needs to make the announcement that
All right. Now, Rob, you've been right where the Perseverance team is sitting now. What's in store for them as we approach landing?
Well, this is the this is the nail-biting time. Fortunately, we still have ones and zeros coming, but very soon, as we approach cruise stage separation, the transmitter on this rover we've been using all the way to get to Mars is going to be turned off. So we will lose our ability to see ones and zeros. But the good thing is, once the cruise stage is gone, there's another radio that will continue transmitting a tone, so that like a flashlight that will allow us to at least see that the vehicle is still on, and that color of that flashlight tells us a little bit what state the rover's in. But soon after that, it won't be very long before we'll be able to hear more ones and zeros coming from the spacecraft. So this is a really exciting time, and it's just important to remind people there's a lot that can go wrong in a day like today. There are thousands of things that have to go right.
Yeah, we had success in the past landing on Mars. You'd think it gets easier, but it really doesn't. Why is it still so difficult?
Well, it's because it's involved thousands and thousands of things, hundreds of thousands of lines of code. There's 79 pyrotechnic devices. Each have to work perfectly. One critical wire short or one key thing mechanism that doesn't work or breaks, and it's mission over. And so it's and it's very easy. We're human beings. We're not perfect. Mistakes can be made. We count on each other to find our own mistakes, and we work very hard to learn from the mistakes of the past. We've had many failures. Remind people, roughly half, around half of the missions to Mars over history have failed. And so that could happen today too. Even though we've had a nice, wonderful string of successes in the United States, it's still still a bit of a gamble that we have hoped that we have erred in the side of luck, and we've stacked the deck and loaded the dice to make this thing succeed. But if we do fail, if something bad happens today, I can tell you, we're going to learn it. We'll have the data that tell us what happened. We'll know why. We'll figure it out. And if we are allowed, we will pick ourselves up and get us back on the horse. And if Congress and NASA allow, we will try again. As we always do, we will learn from our mistakes.
And what are the possible scenarios we could be looking at today?
Well, there's things like one of the key stressful elements for all of us is parachute inflation. But just even separating from the cruise stage is a pretty major event. Lots of devices have to work properly. Certainly, the heat shield separation, getting the descent engine started. There's no less than 16 rocket motors that have to work. 8 to control during entry, another 8 to control it during landing. I said it's a lot of stuff, and it all has to work. And guess what? We haven't done this before with this vehicle ever. This is its first attempt to actually land. We can't try this on Earth. We can't we don't have test pilots to try it out on this planet before the big show. So this vehicle is doing it for the first time. We've done the best testing we could do in bits and pieces, but it's as best as we could do. But I think our team is up to it. This team is the best. It's a diverse, intelligent, amazing group of people. People from all over the world who worked on this, not just here in California, but all over NASA, contributors from aerospace, universities, countries around the world. It is just an incredible, remarkable engineering achievement, and I am just so proud of this team.
Thanks, Rob. Now, let's listen back into Mission Control.
Right, we're about 14 minutes from entry interface. The vehicle is currently preparing the heat rejection system that has kept the thermal system cool inside the air shell for about the last 6 months. This will allow the spacecraft to more easily cut the line in upcoming cruise stage separation, which is under 4 minutes now.
We have now enabled the rover Pyro bus.
That's the pyrotechnic system that's
We're
going to
powering off the cruise stage devices.
And these are the things in the cruise stage that we no longer need. With the pyrotechnic system working, we can explode the devices
the
necessary to
vehicle is
separate.
preparing for the upcoming cruise stage separation in about 3 minutes 15 seconds. by powering off all the devices on the cruise stage in order that they can be safe once the cruise stage is jettisoned.
Yeah, this cruise stage has been very reliable.
We are firing our first pyros to vent the HRS liquid and gas.
This has been the coolant that's kept their vehicle from getting too hot on the way to Mars. We have to vent it into space. And so this is one of the first major events that take place as part of entry, descent, landing.
The HRS vent anchor is complete.
Yes.
We will see the next anchor in approximately 3 minutes.
Okay.
We are currently 12.5 minutes from entry interface. We are coming upon cruise stage separation in 2 minutes and 20 seconds.
What's happening now, Rob?
Okay, well, we're just waiting. The rover is completely in charge. It's doing all the things we've taught it how to do. It's all built into the software. We've tested it over and over and over again. This team has spent 24 hours a day, 7 days a week, testing this thing for years. And so this is really the culmination of all that work. So this vehicle is getting ready to push that cruise stage away. Once it gets pushed away, the entry system with the rover inside, with the rover still in charge, is going to get ready to take the vehicle, turn it to the right orientation, and aim it to Mars, and prepare for entering the atmosphere. This won't be long. Be prepared for this event.
We're about 1.5 minutes from cruise stage separation, about 11 minutes, 20 seconds from entry interface.
Okay, so it's about 10 minutes from cruise stage separation till entering the top of the atmosphere. From then on and out, things happen
We are switching
fast.
to MFSK tones. Telemetry will have stopped.
Telecom is confirming that the spacecraft has switched to broadcasting tones. These tones are received directly from Perseverance, but have very limited information content. We won't receive real-time information until about 9-10 minutes from now, once the Mars Reconnaissance Orbiter starts relaying information from Perseverance. We are under a minute from cruise stage separation, about 10.5 minutes from entry interface.
It's getting exciting. I have to admit, I am quite anxious, but very hopeful that this machine is going to do what we asked it to do.
You're seeing the heartbeat tones.
Okay, that means that there's no more ones and zeros coming. It's just the vehicle telling us it's still alive.
We're continuing to receive tones from Perseverance, standing by for cruise stage separation. We have indication that cruise stage separation has been confirmed by the spacecraft.
We're off on a good start.
In about 1 minute, Perseverance's landing software will wake up and begin the final preparations for entry. The first action it will do is to fire warm-up pulses with its entry thrusters. These pulses ensure that the spacecraft gets the thrust that it wants during entry interface. We're about 9 minutes from entry interface.
Okay, so now the vehicle's on its own. It's turning itself into the direction of facing the heat shield toward Mars, and will eventually hitting the top of the atmosphere. We're not far away. This is going to go very quickly from here on out.
I have confirmation that we got shadowed by the cruise stage as it passed through our beam to the Earth.
Telecom indicated actually that we could see a signal that the cruise stage went between the Perseverance entry capsule and Earth. So we saw a little blip, the data stream indicating the cruise stage separation. We have confirmation that the vehicle has started warming up those entry thrusters. Warm-up pulses have begun. At this point, the spacecraft is trying to stop its spin from the cruise 2 revolutions per minute down to 0, and then will turn to its desired orientation from entry. It will separate the 2 balance masses that has kept it balanced during all of cruise. This will allow the entry capsule to have lift when it enters the atmosphere. We have confirmation that the spacecraft has turned to the desired entry attitude. We are about 7.5 minutes from entry interface.
Okay, the vehicle is pointed in the right direction. The thrusters are warmed up and doing their job. And now we've spun down from the 2 revolutions per minute that the vehicle had the whole way to Mars. It was a spin-stabilized spacecraft. And then from here on out, it's going to just be a bullet, and it's going to control its orientation and attitude via rockets on the back of the back shell.
Points carrier lock. The DTE from Radio Science from Green Bank reports carrier lock. You see the carrier on the downlink.
Flight level 1.
We are continuing to wait for entry interface. We're about 6 minutes and 45 seconds from entry interface. We have confirmation from Greenback that they are receiving direct-to-Earth telemetry via that path. The spacecraft Perseverance is currently transmitting heartbeat tones. These tones indicate that Perseverance is operating normally and has nothing significant to report. This is as expected. We're currently just over 6 minutes from entry interface.
Okay, and now we wait. As soon as we get to the top of the atmosphere, it will be very quickly, which is the entry point. It won't be very long before the atmosphere will start getting thicker and thicker. It's going very quickly at a fairly steep angle of 15 degrees into the atmosphere. And as it starts to slow down.
We're just under, we're about 5.5 minutes from entry interface. We're still receiving heartbeat tones. We expect to continue receiving heartbeat tones until about 5 minutes after entry. At that time, Perseverance will be no longer in view of our antennas here on Earth. About 90 seconds prior to entry, the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do reacquire the signal from Perseverance. We are currently about 4.5 minutes from entry interface. Perseverance continues to report heartbeat tones, indicating everything is nominal.
Okay, what we're looking for now is Mars Reconnaissance Orbiter should be in view soon of our vehicle and be able to listen to ones and zeros coming from a separate radio that's really designed to talk between spacecraft.
MRO reports the Electra radio is powered on, ready to receive signals from the lander.
Okay, MRO is ready and able and waiting to hear from our rover.
Mars Reconnaissance Orbiter has reported that it's ready to receive the signals from Perseverance. It should be in a few minutes here. We're just
Flight Local 1
from entry interface.
We don't need these ones and zeros, as Swati said, but to land safely, but we really need it for our own health and well-being today to keep our nerves under control. But
around this time, a second spacecraft, MAVEN, should begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive heartbeat tones, indicating that everything is nominal. We're currently at about 3 minutes until entry interface.
Okay. Very soon we'll be getting ones and zeros, I hope, from our radio on the rover. The entry interface is nothing more than just an arbitrary place in the sky that we've defined to be above the atmosphere. But from that point on, there's definitely atmosphere, and above it there isn't.
We are 2 minutes from entry interface. Perseverance is to transmit heartbeat tones, indicating everything is nominal.
So the tones can tell us whether something is bad or not is happening. So far the heartbeat is doing well. So the vehicle thinks it's in good shape to land, which is a great sign.
We're just under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second. We're at about 90 seconds from entry interface and standing by for Mars Reconnaissance Orbiter to pick up the telemetry. We are 1 minute from entry interface.
MROs are in receive mode.
We have confirmation that the Mars Reconnaissance Orbiter is now relaying data from Perseverance. We're about 30 seconds from entry interface. Perseverance is going about 5.2 kilometers per second and is about 190 kilometers altitude above the surface of Mars.
Confirm your jet data flow.
About seconds from entry interface. 5.3 kilometers per second and an altitude of about 150 kilometers from the surface of Mars. We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120 kilometers from the surface of Mars. The spacecraft is now waiting until it begins feeling the atmosphere of Mars slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target. Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule. Our current velocity is about 5.36 kilometers per second and an altitude of about 67 kilometers from the surface.
We are probably seeing MRO plasma blackout at this point.
The vehicle should be doing its turns right now.
MRO has lost lock.
Perseverance We have indications that Perseverance is now performing bank reversals in the atmosphere. These are the steps in order to control its distance to the landing target. Perseverance has just passed through the point of maximum deceleration and has indicated that it felt approximately 10 Earth Gs of deceleration.
MRO has lock again.
We saw a small outage of the UHF telemetry from Mars Reconnaissance Orbiter during that peak heating phase, likely caused by the plasma blackout. Perseverance is still continuing to perform bank reversals in the atmosphere to control its distance to the landing target. Perseverance is going about 1 kilometers per second at an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, to the target on Mars, but instead is flying straight to the target.
Parachute.
Our current velocity is about 550 meters per second at an altitude of about 15 kilometers from the surface.
MRO is reporting good telemetry log.
We are coming upon the straighten up. We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Yes.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars. Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Yes.
Perseverance now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
Almost there.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation. We have timing of the landing engines. Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN Safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver.
We've lost direct-to-Earth tones.
As expected. As expected.
Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
UHF is good.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life. At this point, the descent stage has flown away to safe distance. Perseverance is continuing to transmit direct through Mars Reconnaissance Orbiter to Earth.
Oh my God. Oh. Oh.
MRO reports they're still getting telemetry from the lander.
All right, all stations.
We got it.
Touchdown confirmed. We're going to wait for the images.
Wow.
This is so exciting. The team is beside themselves. It's so surreal. Stay tuned. We might get some pictures.
That'd be great.
So much has been riding on this.
Yeah, we just heard the news that Perseverance is alive on the surface of Mars.
It's not the
Flight, we have seen the completion of EDL 3000. Copy activity. That is as expected.
MRO is still seeing a strong signal from the lander.
We have just heard the news that Perseverance is alive on the surface of Mars. Congratulations to the mission. And looks like we have some more news in. It looks like we're getting the first image. Here, take a look at the first image.
Flight, this is OL3. I have the target point on the map when you are ready. We are ready, OL3. Go for it. Flight, I'll be moving in, showing you the safe zone that we've landed in.
Just put the first image from Perseverance on the surface of Mars. Now, it comes from the engineering cameras, known as the Hazard camera. This camera is mainly used to help the rover drive safely around Mars, and we will get higher resolution photos later in the day.
Look at that, right? You get the safe.
Wow. Look at the orange. Nice. This is amazing.
Here's Andrew.
For Steve. Stand by for Steve.
You did it. You did it. You did. You led the team. You made it happen, man. Congratulations,
We just got our second image in. Our second image is in.
Okay, these we have a camera in the front and rear of the spacecraft. They're near the ground, so these are pretty close. So you can see the wheels there, and they're a little dirty because we've got glass covers over these cameras. But we took these seconds after landing, so there's still dust in the air from our landing event. So this is happening. This happened just seconds ago. Just arrived, and this is really amazing. And we even know where we landed. This is the most amazing thing. The vehicle has told us where it's landed because it figured it out. This is a sign. NASA works. NASA works. And when we put our arms together and our hands together and our brains together, we can succeed. This is what NASA does. This is what we can do as a country on all of the problems we have. We need to work together to do these kinds of things and make success happen.
And joining us now is the acting administrator of NASA, Steve Jurczyk. Steve, welcome and congratulations.
Hey, thank you. What an amazing day.
And how does it feel to have another rover on Mars?
It's amazing to have Perseverance join Curiosity on Mars, and just a credit to the team. I mean, just what an amazing team to work through all the adversity that goes and all the challenges that go with landing a rover on Mars, plus the challenges of COVID, and just an amazing accomplishment.
And what does this mean for NASA and its future plans?
So for robotic exploration, every time we execute a mission with new instruments, we discover new things and things we never thought we would discover. So that always informs our future robotic missions, both landers, rovers, and orbiters. This mission also has technology on it. One of the cool things is the Ingenuity helicopter. It's an experiment on this mission, but if it's successful, we can use it as an science observation platform by putting instruments on it, and also use it as a scout for future rover missions, and then just the entry, descent, and landing capability. It'll allow us to land more larger, more ambitious robots on the surface of Mars, and then for human exploration. We have the MEDLI, Mars Entry, Descent, and Landing Instrumentation, which is going to give us EDL information. We have the Mars Environmental Dynamics Analyzer. It's going to give us properties, size and properties of dust particles, because when we send people, we're going to have to deal with that dust. This is just an incredible mission because of the science and the technology, and then caching samples for a Mars sample return mission. That will be an amazing mission, the first round trip to Mars and back, and bringing those samples cached by Perseverance back to Earth to examine with state-of-the-art equipment in our laboratories here on Earth.
We have so much to look forward to. And we also have a student question coming in from Landon. Let's take a look.
Hi, my name is Landon Applegate. I'm in 6th grade and I'm going to Academy for Academic Excellence. And my question is, do you think we could get resources from Mars to help on future missions or even as like a launching point?
Great question, Landon. Actually, we have an experiment called the Mars Oxygen in situ resource utilization experiment, or MOXIE, and it's going to demonstrate generating oxygen from atmospheric CO2, and that could help generate breathable oxygen, and even if we can liquefy it, oxidizer for propulsion systems. So that's a tech demo on Perseverance. And then we're going to continue to characterize the frozen water on and below the surface of Mars, and eventually try to figure out how to extract that water from the Martian soil, or what we call regolith. And then we can use that for potable water and also break it down into oxygen and hydrogen for rocket fuel. So absolutely, we're going to try to eventually figure out how to live off the land to support human missions to Mars.
Thanks for taking the time to talk to us today, Steve.
Thank you.
And now that Perseverance has safely touched down on Mars, let's learn more about what's in store for the rover. Joining us now is Surface Mission Manager Jessica Samuels. Jessica, your surface operations team has now taken over. What are they doing now?
Yes, hi Raquel. We are so excited here in the Surface Mission Support area. The team will do a handover with the entry, descent, and landing team and pass any critical information. And then this team behind us will be the team that does the health and safety assessments daily as we progress on this mission.
And what do the upcoming weeks look like for your team?
So as we enter Mars time now, the commanding team will be working overnight while the rover is asleep so that we can perform the initial checkouts of our key rover functions and our science instruments. And we have to do this all in time for the regularly scheduled communication pass, which happens in the morning. And so we will be working around the clock, making sure that Perseverance is healthy, and we will begin this exciting adventure.
And can you tell me, what's it like living on Mars time?
It's a little bit like constantly, flying and changing your time zone. The rover, on Earth, the rover wakes up at the same time every day, but on Earth, that's 40 minutes later. So the team is going to be shifting our work schedule by 40 minutes as we come into work over the next few weeks. So it'll be exciting and some late nights, but we're also excited and we can't wait.
It's a whole new lifestyle.
Yes.
We also have a student question for you. This is Sophia's video.
Hi, my name is Sofia Lopez, and my question for NASA is, how's Perseverance gonna survive? And here's a drawing that I made from Perseverance thinking about Earth. Thank you.
Well, Sophia, Perseverance survives with a power source that charges its batteries overnight while it sleeps, and it keeps heaters on so that all of our critical electronics can stay warm, as well as our mechanism. But it's really survived by the team that performs the health and safety assessments every day and communicates with the rover and makes sure that she's doing okay.
Well, thanks for your time, Jessica, and good luck living on Mars time.
Thank you. Should be fun.
Let's head back to Marina as she gives us a sneak peek into the future at JPL.
Thanks so much, Raquel. It's definitely bustling behind me. It's not quiet like it was just 20 minutes ago. And congrats to the whole team. What an amazing accomplishment. Mike Watkins is the director of NASA's Jet Propulsion Laboratory. He was the mission manager during the Curiosity rover landing on Mars. Welcome, Mike.
Oh, thanks. Glad to be here. You can see all my mask markings on.
Well, you were just celebrating, and rightly so. Now, you've been around for a number of Mars landings. What makes this one special?
Well, two things. I mean, it's the biggest and best rover we've ever sent to Mars, and it can really, do amazing things in terms of, its own scientific exploration of this habitable environment, at Jezero. But, it's also, as you've heard today, it's the first step in Mars sample return. So really, it's not only doing its own mission, it's setting us up for a series of missions and to bring those samples back. And, a lot of the effort to develop the rover was specifically designed, for that sampling and caching system. It's one of the most complex robotic systems ever made. And having it down safely means Mars sample return continues right on course, and we are moving forward.
Wonderful. Now, JPL has a long history with robotic space exploration. Why do you think it's so important to continue to push those boundaries?
There's a lot of reasons. I mean, obviously, for places that are far away, like Mars, and even farther away, like Europa, right now, robotic exploration is the only way we can make those scientific discoveries and really understand these early habitable environments. In the case of Europa, maybe it's even still habitable. And, we're not ready to go there with astronauts yet, but the robots are ready to go there. And so we always, are forerunners and pathfinders of human exploration. And we start by sending, our eyes and arms there in the form of a robot. And it is just fantastic to be able to do that and to learn from each rover, learn from the science and the engineering, and make the next one better and make more and more discoveries. And every time we do one of these missions, we make fabulous discoveries. And each one is more exciting than the last.
The future does look exciting. Now, as director of JPL, what would you like to say to those teams right now celebrating?
Oh, obviously they have earned it. Let me tell you. I mean, they have worked, for years and years on this mission. And then in the past year, of course, we had the COVID experience. And I want to thank not only the team, but also, all of JPL. A lot of folks had to pitch in here, in terms of making sure our remote telework, our IT systems were good enough to support folks working from home. All of the folks looking at PPE and our safe distancing and reconfiguring facilities to make them safe for the employees. It's just an incredible amount of work by the entire lab, and of course, especially by this team. And and in one sense, the 7 minutes of terror are very exciting. But on the other hand, the mission's just started, right? We built the mission, not to land, but actually to drive and get the samples and do other technology, demonstrations. And so, for much of the team, this part of the mission's over. But for most of the team, the mission's really just starting. And so, I think they're very excited. But everybody, I think, can take a deep breath and a sigh of relief now that we are safely down on the surface.
Yes, that collective sigh of relief, and I hear a lot of excitement and celebration behind me as well. So thanks so much for joining me, Mike.
It's my pleasure, and thanks to everyone for joining us, too.
Congrats again to the Mars 2020 Perseverance team for a successful landing. Back to you, Raquel.
Now, there will be a flight test coming up for the Ingenuity Mars helicopter, and if this technology experiment is successful, it would mark the first time we have taken a power-controlled flight on another planet.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has just been very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height.
We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight tests at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. But it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
Mimi Ong is the project manager for Ingenuity. She joins us now as they await a chance to check out their helicopter in the coming days. Welcome, Mimi.
Thank you, Marina.
Oh my goodness, we've been talking about this for months, Mimi. Did you ever think you'd be here at this point? I mean, what's going on in your head right now?
This is super exciting. We have been working on Mars helicopter for over 6 years, testing and carefully designing it for operation at Mars. So what's going through my mind? Ingenuity Mars helicopter is finally at the destination that it is designed for.
Now that Ingenuity is on Mars, what is the timeline you hope to accomplish as you move forward?
We have a series of major milestones between now and Ingenuity's first flight. So tomorrow we'll turn on the helicopter and its base station to confirm health after experiencing the dynamics through the EDL just now. And the next major milestone will be when the rover deploys the helicopter to the surface. And that marks the first moment that Ingenuity operates on its own in a standalone manner. And surviving that first cold, frigid night of Mars will be a major milestone. We'll execute a series of checkouts, and then we will perform that very important first flight. And if the first flight is successful, we have up to 4 more flights in the 30 Martian days that we have set aside for our flight experiments.
And that's when you finally can breathe, right, Mimi? Yes. Now, why is it so important to have that aerial dimension to space exploration?
A helicopter flying far ahead of rovers and astronauts in the future can provide high-definition reconnaissance information for the rovers and the astronauts before they take the long journeys. And as importantly, being able to fly will enable us to get to places that we cannot get to with rovers and astronauts, like sites of steep cliffs, deep inside crevices, areas of high scientific interest. It will be game-changing.
Game-changing is right, and we've talked about this a lot. You've mentioned the risk is huge, Mimi, but the reward is high. What will be your greatest reward?
Our team started with the question of whether a helicopter can fly at Mars, given the extremely thin environment. And we systematically demonstrated a series of technical steps. We demonstrated lift first, and then we demonstrated lift and the first ever powered control rotorcraft flight in simulated Mars atmospheric density. And then we went on to build the full-up helicopter that can not only fly, but operate and survive autonomously at Mars, all under 1.8 kilograms, about 4 pounds. And each of these major milestones have been a first. And the success at each of these has been so rewarding. And along the way, the rewards just kept coming. And I have to tell you, at this moment, it's going up exponentially. So after all these tests, analysis, simulations, and more tests on Earth, our team now gets a chance to test, prove, and learn how it works in the actual environment of Mars. Our team can't ask for a bigger reward than that.
Oh, Mimi, I'm so happy for you and your team. And now we're going to take a question from social media on Instagram for you. At Not Vibhuti asks, is the helicopter going to be doing science?
Well, the helicopter Ingenuity is a technology demonstration, and we are demonstrating the ability to fly and learning how to fly for the very, very first time. And so this is a technology demonstration and a pathfinder for future larger rotorcraft, future missions that will carry much larger instruments. So on this mission, we're not doing any science. We're concentrating on engineering data. How did the vehicle perform? And as you saw Bob Belram in the video before, we will be taking a few first ever color pictures from the flying aerial vantage point, but they'll be icing on the cake. For this one, this is all about engineering data and how do we fly compared to all our tests we have done on Earth.
Mimi, so much for your team and the future generations of scientists and engineers to look forward to.
Thank you.
Thank you so
Great
much
day.
for joining us, Mimi, and good luck to your team with that first test flight.
Thank you so much.
Now, we look forward to the Perseverance rover and Ingenuity helicopter beginning their journeys on Mars as their adventures are just about to start. Go Perseverance and go Ingenuity. Back to you, Raquel.
Thanks, Marina. Landing on Mars is never easy, but this team has persevered, and NASA's 5th rover is on the red planet. You can still hear them buzzing in the back right now. And to get the latest updates on Perseverance as it explores Mars, follow at NASA Persevere on Facebook and Twitter. I'd like to thank everyone watching for joining us today. And to the students and teachers tuning in, we hope you learned a lot from today's landing, and thank you for all your questions. We have a news briefing coming up at 2:30 p.m. Pacific Time. That briefing will wrap up the day and include reactions from Perseverance team members. We'll leave you now with some of the landing celebration photos you've shared with us, set to Youngblood's cover of David Bowie's Life on Mars. I'm Raquel Villanueva. Thanks for watching.